Hello, my name is Andy Heaps, and in this talk I hope I can show that by adding CF metadata to files you will enable the use of powerful software tools for the analysis and plotting of data. To underline this, I'll show you the CFView data interface, which is a quick look data exploration tool for earth science data. CFView is underpinned by the CFPython Earth Science Data Analysis library written by David Hassel and Sadie Bartholomew. This library does the heavy lifting of data input and output, the slicing and dicing of data, and the statistical collapses along dimensions, such as a mean or a maximum value. CFView also uses the CFplot plotting library written by myself, and this plots contour, vector and line plots. The CF in the names in this Python software stack is used to indicate that CF is intrinsic to them and built into them from the ground up. So without further ado, let's load in some data to CFView and see what it looks like. So I have a file called ggap, so I type CFView ggap.nc. And this is my MacBook, as you can see from the title there, and the CFView GUI interface pops up, and if you concentrate on the upper left hand side, you can see we have 13 fields starting at 0 because we're using Python here, and the field names, this is the first bit of CF that you will see. These are the standard underscore names in the fields. If there's not a standard underscore name, then it will try and use the long underscore name instead. So you'll see that there are values for NX, NY, NZ, and NT. So CF viewers realized that these are X, Y, Z, and T values corresponding to longitude, latitude, pressure or height and time. So we have all of our fields have 320 in X, 160 in Y, and 23 in Z, and just one time. So I'm just going to scroll down to our first test field, and this is air underscore temperature. And if you have a look on the right hand side, the dimension view panel, you can see that there's a series of values there for the X dimension, which is the one highlighted down below, and it starts at 0, so that's the Greenwich meridian, and it goes through to almost back to the Greenwich meridian again, just one X value away from there. So that's the X, where Y goes from almost the North Pole, not quite the North Pole, to almost the South Pole. And our Z values go from 1,000, and I know this is pressure, so that's 1,000 millibars, so that's the surface, all the way up to 1 millibar. And our time values, there's just one time value, so that's the 21st of January 1964. So let's make a plot. So there's a little drop-down menu up at the top up here, and that's set to be contour and XY by default. So let's make a plot, and you'll see that it understands that it's a map plot because we've defined our standard underscore name for the X direction to be longitude, or that its units are degrees underscore east. So that's the second bit of CF that we have in there. We can also see that it picked off the first value in the pressure coordinate system, so that's 1,000 millibars, and also just the one time, so it labels things appropriately at the top up there. It also puts the units on the colour bar down below and selects a non-divergent colour scheme. In this case, this is Viridis from Matplotlib, because there's no 0 in our contour levels. So that's our first plot. You'll also see that one of the features of CFView is that it outputs code into the output messages panel. So you'll see here there's 5 lines of code. So we import CF plot as CFP. So that's the 2 library imports that we need. We have read our data set in with a 3rd line. We've specified that it's the 7th index with brackets 6 brackets. So that's the air temperature. We've done a CF Python subspace method on the data and selected the 1000 millibar level, and then we just do a CF plot contour command as the last line. So that's quite powerful. That sort of selects your data and plots it. So that's our first example. Our second example, we're going to change to eastward wind, and we're going to do a zonal mean, zonal wind, so we can look at the jet structure. So I'll do a Y versus Z. So we've got all these longitudes highlighted at the moment. So from 0 to 358 as before. Let's do a transform, and we're going to do a statistical collapse along X. So here we're going to do a mean, and it's a zonal mean because it's a longitude axis. So when I change this, you'll notice that, let's move that back in again. Well, notice that the values on the right in the dimension for X go from all those values down to 1 value. And that's another bit of CF. So we need to know what the bounds are for each of these data points, and this is defined in the bounds variable associated with the X dimension. So that's another bit of CF that's important to have within your data. So now if we just do a plot of that data, we see that we have just our central point of the data set, 179.43, and the atmosphere is the right way up. So there's another CF attribute in there called positive that tells CF Python and CF plot which way is up or down in the atmosphere or in the ocean. You might have height in kilometers on the left hand side instead of pressure in millibars. So that would be different. That would be an ascending number instead of a descending number. And another bit of CF is the cell underscore methods, and that's as we've changed our data, so we should really inject a little bit of information into our field to tell it that we have done a mean over longitude. So that's what the cell underscore methods attribute says. So let's reset our data and just go back to air temperature again. There are a variety of other things you can do in CF view, and another one is a line plot. You can do vectors over contours and trajectories as well. But this last example, I'll do a line plot, and we're going to go along X, and which is longitude, and let's select something like 57 degrees north, and we are going to use 1000 millibars because that's the surface of the Earth. And if I do plot for a line plot, you get a line plot pops up. Scaled. CF Python knows that this is a longitude axis along the bottom, so it changes the axis labels from just numbers into degrees east and degrees west like 120 West, for example. So that's it for a quick demonstration of CFU. If you would like to have a go at using CFU, it's available on the Jasmine and Archer 2 facilities in the UK, for those who have access to those. It is also a simple 2-line install process for our supported platforms of Unix and Macs. Simply do a web search for cf-view and look on the download/install page. I'd just like to finish off by saying that, in summary, why should you use CF? If you do use CF in your data, you get access to tools that make your life easier and enable you to analyze and plot your data much more quickly. This in turn will allow you to spend more time on the science side of your project rather than on the technical aspects of data analysis and plotting.